Welcome to the deep dive. Today we're going to be looking at something really fascinating. We're diving into these patents from Salvatore Cesar Pais.
Okay.
You know, you've sent in so many sources, research articles, and notes,
Yeah.
and even the patents themselves,
Mm-hmm.
all because you're so curious about Pais' ideas, really for revolutionizing propulsion and energy.
Right.
We're talking about reducing a craft's mass, creating gravitational waves,
Right.
achieving room temperature superconductivity. Or
Wow.
you ready to kind of have your mind blown a little bit?
I am very excited. It's quite a collection of concepts, to say the least.
Yeah.
These patents really do push the boundaries of what we typically consider possible with technology.
Yeah, let's just jump right in. Let's
Okay.
start with this inertial mass reduction device. The patent actually claims to reduce the mass of an entire craft.
Yeah.
Honestly, it sounds like something straight out of science fiction.
It does have that kind of like warp drive vibe, doesn't it?
Yeah.
But the patent grounds its claims in manipulating something called the quantum vacuum state. Okay,
Okay.
so imagine a vast, unseen sea of energy that permeates the entire universe. That's the quantum vacuum. Pace believes that by creating a specific kind of resonant cavity and bombarding it with high-frequency electromagnetic waves, we can create a sort of disturbance in this sea,
Okay.
a localized region of what he calls negative pressure.
Okay, so I'm trying to picture this. So we're not actually shrinking the amount of matter in the craft,
Right.
but somehow changing how it interacts with space-time.
Exactly. And that region of negative pressure, according to Pace, could counteract the craft's inertia,
Okay.
making it easier to accelerate to incredibly high speeds.
Wow.
Now, to support his theory, Pace cites some controversial gyroscope experiments
Okay.
that showed unusual weight reductions under certain conditions.
Okay.
These haven't been widely replicated or anything like that.
hmm
But the core idea is that manipulating the quantum vacuum, which we know exists because of things like the Casimir effect, those weird forces between objects in a vacuum might actually have measurable effects on mass and gravity.
So it's theoretically grounded, but still very much in the realm of speculation.
Right.
What's fascinating to me is this concept of the quantum vacuum plasma, or QVP.
Hmm.
Pace calls it the electric glue of the universe. Can you break that down for us?
Yeah, well, it's a bold statement for sure.
Yeah.
But think about the Casimir effect again. Why do those plates in a vacuum experience a force? The current understanding is that it's due to the quantum fluctuations of the vacuum itself.
Okay.
The QVP, in Pace's view, is like a fundamental fabric underpinning reality, full of potential energy just waiting to be tapped.
Mind-blowing stuff. And he's proposing that we can actually manipulate this fabric to achieve these seemingly impossible feats.
That's the core concept running through all these patents. But
Yeah.
to do that, Pace suggests a device he calls a high-energy electromagnetic field generator,
Okay.
or HAM-FG.
Him shit.
Oh,
But
yeah.
this is key to generating those powerful electromagnetic fields he needs to manipulate the vacuum state.
Okay, the patent gets pretty deep into the technical weeds of this heat MFG with equations for energy flux and even the vacuum energy density itself.
Right.
Without going into all the math, can you give us the ELI5 version of how this thing is supposed to work?
So imagine a device that can crank out electromagnetic fields far more intense than anything we can create today. Those fields, according to Pants, are the key to unlocking these exotic effects, possibly even triggering a cascade of particle-antiparticle creation,
Okay.
further amplifying that vacuum polarization effect.
So theoretically, it's a feedback loop of incredible energy and strange quantum effects.
Right.
But building something like this in the real world has got to be an engineering challenge of epic proportions, right?
To put it mildly, yes.
Yeah.
The energy requirements alone would be absolutely staggering. We're talking about levels of control over electromagnetic fields that are completely unprecedented. So groundbreaking in theory, but maybe a few centuries away in practice.
Perhaps. But remember, the beauty of science is that sometimes just asking the question and laying out a theoretical framework is the first step. Who knows what kind of seemingly impossible breakthroughs might stem from this line of thinking?
Speaking of breakthroughs, Pais also has a patent for a high-frequency gravitational wave generator. Until very recently, even detecting gravitational waves was considered a monumental achievement, and now he's talking about generating them.
It's certainly ambitious.
Yeah.
The basic idea is to exploit something called the Gertzenstein effect. It's a theoretical process where electromagnetic radiation, when passed through a static magnetic field,
Okay.
can be converted into gravitational waves.
So we're using light to create ripples in space-time itself.
Yeah.
That sounds unbelievably complex. How would you even build something like that?
Pace proposes using nested electromagnetic fields.
Yep.
So imagine a field within a field generated by microwave emitters and acoustic resonators, all vibrating at very specific frequencies. It's this precisely tuned vibration that he believes can trigger the Gertzenstein effect and produce those elusive gravitational waves.
The potential applications he lays out are pretty mind-boggling. Things like advanced spacecraft propulsion, even disrupting asteroids.
Yeah.
But wouldn't the energy needed for that be astronomical?
It would be a challenge, to say the least.
Yeah.
The patent focuses on the theoretical possibility, not so much the practical engineering.
Right.
Still, the idea that we might one day generate and control gravitational waves is a fascinating one, even if it's a long way off.
Okay, let's move on to the third patent, the piezoelectricity-induced high-temperature superconductor. Now, achieving superconductivity at room temperature is a holy grail for so many technologies. Lossless energy transmission, incredibly efficient electronics, the possibilities are endless.
It would be a true game changer. Imagine a world where energy flows freely without any loss, where electronics are lightning fast and incredibly energy efficient. But how does Pace propose to do it? That's where things get really interesting.
From what I understand, it involves a special wire and, get this, vibrating it.
Oh,
How does shaking a wire make it superconductive?
right.
That's where I'm getting lost.
It's not just any wire.
Okay.
Pace describes a composite wire with an insulator core and a thin metallic coating. Now, piezoelectricity is the ability of certain materials to generate an electric charge when subjected to mechanical stress. Pace proposes that by vibrating this wire in a very specific way while passing a pulsed current through it,
Okay.
we can induce superconductivity even at high temperatures.
So we're using vibrations and electricity to achieve a quantum state where electrons flow freely. That sounds like a pretty delicate balancing act.
Right.
How does Pace even begin to justify this?
It goes back to that idea of pushing a system far from equilibrium. Pace believes that the abrupt, accelerated vibrations, combined with the pulsed current, create a highly nonlinear state in the material. He argues that this disrupts the normal behavior of electrons, forcing them into a synchronized wave-like state.
This synchronized state, is that what's called macroscopic quantum coherence?
Precisely. It's a state where quantum effects, usually confined to the microscopic world, become observable at a much larger scale. Imagine electrons, normally behaving like individual particles, suddenly acting like a synchronized wave, all moving together without any resistance.
Yeah.
That's what allows electricity to flow without any loss in a superconductor.
So he's using this very specific type of vibration combined with a pulsed current
Right.
to essentially force the electrons into this synchronized state.
That's the core concept. He's
Huh.
drawing on a concept called the Prigogine effect,
Yeah.
which describes how a system far from equilibrium under specific conditions can spontaneously self-organize into a more ordered state,
Okay.
like using chaos to create order.
The patent goes deep into the specifics of this, even mentioning things like the London penetration depth, which relates to how far a magnetic field can penetrate a superconductor, and the Meissner effect, which describes how superconductors expel magnetic fields. He's not just throwing out a vague idea here. He's trying to lay out a theoretical framework for how this might actually work.
And that's what makes these patents so fascinating. Even if the practical challenges are immense, Pace is asking profound questions about the nature of reality and exploring the boundaries of what might be possible.
What's striking to me is that all three of these patents, as different as they seem, share this common thread. The manipulation of the quantum vacuum and this idea of pushing systems far from equilibrium.
Yeah.
It's almost like he's found a fundamental key, and now he's trying to figure out which locks it opens.
Right.
The implications, if any of this turns out to be achievable, are truly mind-boggling.
It's a future that could completely redefine our relationship with energy, space, and even time itself. But before we get too carried away with the what-ifs, let's delve a little deeper into the connections between these patents. What are some of the common threads that tie these seemingly disparate ideas together?
Yeah, that's a great question. It's clear that Pace is obsessed with the quantum vacuum and this idea of pushing systems far from equilibrium. But how do those concepts actually translate into real-world devices?
Well, what's fascinating is how Pace consistently uses specific techniques to disrupt a system's equilibrium, preventing it from settling back into a stable state. Think about it vibrating a resonant cavity, spinning a charged shell at high speeds,
Yeah.
even shaking a wire. These are all ways to introduce what he calls controlled chaos into a system.
It's like he's trying to trick the universe into revealing its secrets by constantly throwing it off balance. But why is this far from equilibrium state so important?
That's the million-dollar question. Pace seems to be suggesting that this state of controlled chaos is crucial for accessing those extraordinary effects he's after. It's like a hidden door that only opens when the system is in a state of flux, of instability.
So he's harnessing chaos to create order, using instability to unlock those hidden potentials within the quantum vacuum.
Yeah.
It's almost poetic in a way.
It does have a certain elegance to it, doesn't it? And it speaks to the interconnectedness of everything. You know, the idea that the most profound discoveries often lie hidden in the most unexpected places.
One thing that keeps popping up in all three patents is this emphasis on accelerated motion. He's not just talking about movement, it's specifically about acceleration. Why is that so important?
That's a key insight. Pace isn't just talking about any kind of motion. He's specifically focused on the acceleration of charged matter. According to classical electromagnetism, accelerating charges emit electromagnetic radiation. But Pace seems to be hinting at something even more profound.
Okay.
He suggests that accelerating charged matter in very specific ways can directly influence the quantum vacuum state itself.
So it's not just about creating electromagnetic waves. It's about using those waves to actually interact with and manipulate the very fabric of reality. That's a pretty heavy concept.
It is, and it's where we start to see those connections between the patents emerge.
Right.
You remember how the inertial mass reduction device is all about polarizing the vacuum to create that region of negative pressure?
Right. Well, in the gravitational wave generator, the accelerated vibration of charged surfaces is also seen as a way to amplify the electromagnetic energy flux, making that Gertzenstein effect we talked about even more pronounced.
So in both cases, we're using the accelerated motion of charged matter to essentially pump energy into the system, creating those extreme conditions needed to manipulate the quantum vacuum.
Exactly. And it's not just about energy, it's also about coherence. Remember how we talked about macroscopic quantum coherence being crucial for superconductivity?
Right.
Pace argues that the accelerated vibration of the wire in his superconductor patent is key to achieving that state. It's about keeping those delicate quantum correlations from being destroyed by the normal thermal fluctuations that occur at higher temperatures.
It's like a constant battle between order and chaos, and Pace is using accelerated motion as his weapon to tip the scales towards order, towards those macroscopic quantum effects. That's a brilliant way to put it. And it highlights the fundamental challenge he's grappling with: how to maintain those delicate quantum correlations in the face of entropy, the natural tendency towards disorder.
If Pace is right, and these effects can be achieved, we're not just talking about building new machines, we're talking about a whole new era of engineering.
Yeah.
One where we're manipulating the very forces that govern the universe.
It's a truly awe-inspiring prospect. Okay, are you ready to dive into some more technical details?
Yeah.
Let's revisit the high-frequency gravitational wave generator and see what's going on inside that thing.
Yeah, I'm all for getting into the nuts and bolts. From what I remember, the patent describes this gas-filled shell with a charged outer surface, surrounded by microwave emitters that make it vibrate.
Right.
But then it gets even weirder with these inner cavities. Can you break that down for us?
So picture this: a gas-filled shell shaped like a sphere with an outer surface that can be electrically charged. This shell is surrounded by microwave emitters, kind of like tiny antennas that bombard it with energy, causing it to vibrate at a specific frequency.
Yeah.
But here's where things get interesting. Inside this shell, there are two more cavities also filled with gas,
Okay.
and they're designed to rotate in opposite directions.
Hold on. Cavities within a cavity. It's like a Russian nesting doll of electromagnetic weirdness.
Yeah.
What's the purpose of these inner cavities?
These inner cavities are where the real magic happens. Just like the outer shell, they have electrically charged surfaces. But instead of being vibrated by microwaves, they're vibrated by sound generators. And these cavities are designed to spin in opposite directions, which Pace's claims is important for stabilizing the whole system.
So I've got this outer shell vibrating at microwave frequencies and these inner cavities spinning and vibrating at acoustic frequencies. And somehow, this intricate dance of vibrations is supposed to generate gravitational waves.
It's definitely a complex system, but the core idea is that the interaction between the electromagnetic fields generated by the outer shell and the inner cavities is what triggers that Gertzenstein effect. Remember, that's the theoretical process where electromagnetic energy can be converted into gravitational waves.
So the sound waves are just a way to create those specific vibrations in the inner cavities that are needed to interact with the electromagnetic field from the outer shell.
Exactly. And the patent delves into quite a bit of detail about the precise frequencies and energy levels involved. Paisley even suggests that these waves could be powerful enough to have a significant impact on matter, going so far as to mention the possibility of disrupting asteroids.
Okay, let's put on our skeptic hats for a moment.
Mhm.
The Gertzenstein effect is still just a theoretical concept, and the energy levels required to generate gravitational waves strong enough to disrupt an asteroid would be absolutely mind-boggling. Are we really expected to believe that this is feasible?
You're right to be skeptical. The patent is heavily focused on the theoretical framework, and the practical engineering challenges are immense, to say the least. We're talking about manipulating energy on a scale that's currently beyond our capabilities.
So, while the idea of gravitational wave generator is fascinating, it's probably safe to say that we won't be blasting asteroids out of the sky anytime soon.
Probably not. But that doesn't mean we should dismiss these ideas entirely. Who knows what kind of technological advancements might stem from this kind of outside-the-box thinking? Perhaps it will lead to new ways to manipulate gravity, new forms of propulsion, or even new communication technologies that exploit the unique properties of gravitational waves. It's the exploration of these possibilities that truly drives scientific progress.
Okay, let's shift gears again and talk about that piezoelectricity-induced high-temperature superconductor. I'm still struggling to grasp how vibrating a wire can induce superconductivity. Can you walk us through the logic here?
Absolutely. The key is to remember that Paces isn't talking about just any wire. He's proposing a very specific type of composite wire with an insulator core and a thin metallic coating,
Right.
possibly made of aluminum. He's also very specific about the type of vibration it needs to be abrupt and accelerated, creating a highly nonlinear, far from equilibrium state in the material.
So it's not just about shaking the wire. It's about shaking it in a very specific way.
Right.
Almost like you're shocking the material into a superconducting state.
That's a great way to put it. And he's not just relying on vibrations, he's also passing a pulsed electrical current through the wire,
Hmm.
adding another layer of complexity to the system. He believes this combination of abrupt vibrations and pulsed current creates the conditions necessary for macroscopic quantum coherence.
Right, that synchronized wave-like behavior of electrons that allows electricity to flow without resistance. But how does he connect these abrupt vibrations and pulsed currents to the emergence of this macroscopic quantum coherence?
He draws upon a concept known as the Prigogine effect, which we discussed earlier.
Right.
This effect describes how a system, far from equilibrium, can under very specific conditions self-organize into a more ordered state. Peos argues that the abrupt vibrations and pulsed current, combined with the nonlinear nature of the composite wire, create those specific conditions, essentially forcing the system to self-organize into a state of macroscopic quantum coherence.
He's using chaos and instability in the form of these vibrations and pulses to trick the system into becoming a superconductor, even at high temperatures. It's a pretty radical idea, isn't it?
It is. And he goes even further, exploring various techniques to enhance these vibrations and control their effects. He mentions using a piezoelectric coating on the wire, which would allow him to electrically induce those vibrations,
Okay.
potentially making the whole system more controllable and efficient.
And he even talks about using electromagnetic coils to generate even more complex magnetic fields around the wire, further amplifying those spin fluctuations and potentially enhancing the superconducting effect. It's like he's pulling out all the stops, using every trick in the book to achieve this room temperature superconductivity.
He's definitely not holding back, and it's important to remember that even if this specific approach doesn't pan out, the insights he's generating about the interplay between non-equilibrium thermodynamics, macroscopic quantum phenomena, and material properties could have far-reaching implications for other fields of research.
Absolutely. Even if we're not plugging our phones into room temperature superconductors anytime soon, the exploration of these concepts is pushing the boundaries of our understanding of the universe, and that's always a good thing. What are some other intriguing details from these patents that we haven't touched upon yet?
Well, one that caught my eye was Pice's discussion of the isotope effect in his superconductor patent. This effect describes how the critical temperature of a superconductor can change depending on the isotopes present in the material. Isotopes, as you might recall, are atoms of the same element that have different numbers of neutrons. Pice suggests that in his wire, the critical temperature could actually be scaled with the square of the vibration frequency of the ionic mass.
Okay.
Essentially, the faster you vibrate the wire, the higher the critical temperature might become.
Okay, now that's pretty mind-bending. So it's not just about creating vibrations, it's about the frequency of those vibrations and how that frequency affects the quantum interactions within the material.
Precisely. It all ties back to that fundamental concept of non-equilibrium thermodynamics. Pi seems to be suggesting that by pushing the system further and further away from equilibrium, by increasing the frequency and intensity of those vibrations, we might be able to access new and unexpected quantum effects.
It's like he's saying there's a whole hidden world of quantum phenomena just waiting to be unlocked, and the key is to create the right kind of chaotic, far from equilibrium conditions.
Yeah.
Let's go back to the inertial mass reduction device for a moment. I'm still fascinated by this idea of creating a region of negative pressure to counteract inertia. Does he provide any specifics about how this would actually be used in a craft?
The patent itself doesn't delve into a complete spacecraft design,
Okay.
but it does offer some intriguing hints. For instance, he describes the resonant cavity as potentially being an annular duct,
Okay.
which is essentially a donut-shaped tube.
Okay.
He also mentions a frustum, which is like a cone with the top sliced off.
So we're talking about a donut-shaped resonant cavity and a cone-shaped craft.
Mhm.
Sounds like something out of a Dr. Seuss book.
It's definitely a unique visual. He even suggests that this frustum could be rotatable, potentially adding another layer of control to the system. And he talks about incorporating conventional propulsion systems
Right.
like chemical rockets,
Yeah.
nuclear engines, or even a Visimer engine, which is a type of plasma-based propulsion system.
So it's not just about the inertial mass reduction device itself. It's about integrating it with existing propulsion methods to create a truly hybrid craft.
Exactly.
Mhm.
And he even mentions the possibility of using a Faraday cage to shield the crew and sensitive equipment from the intense electromagnetic fields generated by the device. He seems to be thinking about the practical implications of this technology,
Right.
even if the details are still quite vague.
So while we might not have a complete blueprint for a pace-powered spacecraft just yet, we're starting to get a glimpse of what such a vehicle might look like and how it might operate.
It is exciting to imagine, isn't it, to think that we might one day be able to travel through space using a technology that exploits the very fabric of reality itself.
Okay, we've covered a lot of ground here. I'm curious what stands out to you as the most intriguing aspect of Pei's work.
You know what I find most compelling is that Pace isn't afraid to ask big, audacious questions
Yeah?
and to challenge the boundaries of what we think is possible. These patents are dense with technical details, complex physics, and at times even a bit of poetic speculation. But underneath it all, there's a sense of wonder, a drive to explore the unknown, and a willingness to push the limits of human ingenuity.
Absolutely. Even if not all of his ideas turn out to be feasible, the very act of asking these questions, of pushing the boundaries of our understanding, is what drives scientific progress.
Precisely. These patents aren't just about building new machines, they're about expanding our horizons and imagining a future where we can harness the most fundamental forces of the universe to achieve things that today seem like science fiction.
And who knows, maybe one day those science fiction dreams will become scientific reality.
Yeah.
It's like he's opened a door to a whole new world of possibilities, and we're just beginning to explore what's on the other side.
Right.
But I have to ask, is Salvatore Pais a visionary genius, or are these patents just incredibly detailed works of science fiction?
That's the question that keeps swirling in my mind, as I delve into these concepts. There's a fine line between groundbreaking innovation and speculative fantasy,
Right.
and Pi seems to dance along that line with remarkable audacity.
Yeah.
On one hand, his ideas are deeply rooted in theoretical physics, drawing upon established concepts like the quantum vacuum, the Gertzenstein effect, and non-equilibrium thermodynamics.
Right.
He's not just throwing out random ideas, he's crafting detailed theoretical frameworks and equations to support his claims.
Yeah, he's definitely not afraid to dive into the mathematical weeds. But on the other hand, the sheer scale of the engineering challenges involved is almost unimaginable. We're talking about manipulating energy and matter in ways that are currently far beyond our technological capabilities.
Precisely. And that's where the skepticism comes in.
Yeah.
Can we really create resonant cavities that can generate negative pressure? Can we build devices that can generate gravitational waves strong enough to disrupt asteroids? Can we truly achieve room temperature superconductivity through piezoelectricity? These are questions that will likely remain unanswered for many years, if
Yeah.
not decades to come.
So how do we reconcile these seemingly contradictory aspects of Pace's work? The rigorous theoretical grounding versus the seemingly insurmountable practical challenges.
I think the key is to view these patents not as blueprints for immediate technological development, but as thought experiments, as invitations to explore the frontiers of physics and to challenge the limits of what we believe is possible. PACE is asking us to consider a future where we might be able to manipulate the very fabric of reality to harness forces that we've only begun to understand.
It's a future that's both exhilarating and a little bit daunting. Imagine a world where spacecraft could travel faster than the speed of light, where energy flowed freely without any loss, where we could control gravity at will.
Right.
It's a world that would fundamentally reshape our understanding of the universe and our place within it.
It's a world that's both tantalizingly close and perhaps impossibly far away.
Yeah.
But even if we never fully realize Pace's vision, the very act of exploring these ideas can lead to unexpected breakthroughs and advancements.
It's like planting seeds that might not bear fruit for generations to come.
Mm.
But those seeds have the potential to grow into something truly extraordinary.
Absolutely.
And that's what makes this deep dive into Pice's patents so rewarding. It's not just about the technology itself. It's about the power of human imagination and our relentless drive to explore the unknown.
I think that's a beautiful way to sum it up. These patents are a testament to the boundless potential of human creativity and our insatiable curiosity about the universe and our place within it.
We've covered a lot of ground today, from the theoretical underpinnings of Pice's ideas to the potential applications of his technology.
Yeah.
We've explored the complexities of the quantum vacuum, the mysteries of gravitational waves, and the promise of room temperature superconductivity. It's been a truly mind-expanding journey.
It has been a fascinating exploration, to say the least, and I hope our listeners have gained a deeper appreciation for the power of scientific inquiry and the importance of pushing the boundaries of what we believe is possible.
Absolutely. As we wrap up this deep dive, I want to leave you with a final thought. What if Pelez is right? What if, somewhere within these patents, lies the key to unlocking a future that we can barely even imagine? What if the impossible is, in fact, within our reach? These are questions worth pondering as we continue to explore the frontiers of science and technology. Thanks for joining us on this incredible journey